30 to 50% of your fractures produce 80% of your hydrocarbons.
That lends a lot of credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those, and the computer is raising weight on bit, and I miss any of those, I have a train wreck. Computer's going in the ocean.
Here's your new colors, here's your new thing. We don't do that
at all. Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hello everyone. Welcome to the Locksmith door. I can't say it.
V-door locksmith.
V-door locksmith.
All right, there's my beautiful Brooklyn. All right, everybody, welcome to the V-door Locksmith Show. I'm your host, David Gibson. So excited to be here with you guys on this Friday, where we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, and one technical screw up at a time. Please let me know where you guys are watching from. Let me know if you can hear me. Always a challenge to make sure that the microphone and audio is working. So yeah, let me know if you guys can hear me. Trying to think. It's been a very interesting week. Spent a couple of days this week out in West Texas. Got to visit a handful of rigs, filmed some footage for a couple of clients, helping them out with their marketing stuff. It was absolutely amazing time. Got to see and meet a whole bunch of new people that are putting boots on the ground out in West Texas. It's always great to be able to see what's actually taking place. What are the complaints? What are the things that are taking place that, either I can help with or people here in the industry. So we keep bringing you guys interviews just like this to be able to help those that most of the time don't get to be able to attend a lot of the industry events where you have technical presentations and stuff that are happening, in Houston or in San Antonio, Austin. And so this is one of those opportunities. We really like to be able to bring the technical presentations digitally and online so that those out there in the field can be able to partake as well. So one of the big things for today. All right, like I said, guys, let me know where you guys are watching from. We'd love to be able to give you a shout out here on the screen. Let's see where everybody's watching from this morning. James Hudson, it looks like he's got his popcorn ready, or that might be McDonald's French fries. I can't quite tell. All right. And we got Aaron Webb tuning in from Cyprus. Thank you for being here. John DeWart says, good morning from Colorado. Thank you for being here, sir. Cohen, good greetings from Saudi. All right. Nice little international show. Good morning, David. And US, I look forward to the show. Are you back in the US? Is that what you mean, Paul? All right. He's spent a lot of time. Frank's tuning in from Anchorage, Alaska. Thank you, sir. James says, loud and clear. Awesome to be here. Awesome. All right. Eric from sunny south of France. Man. Paul he's in Saudi. All right. Derek Boy says, good morning from the Permian. Thank you for being here, sir. Do appreciate it. All right. We got plenty of people watching this morning. All right. Good show. LinkedIn just getting hectic. Yes. So anybody that's watching, if you guys are having troubles with LinkedIn, and I don't know if you guys will even be able to hear this, if you're having problems with LinkedIn, jump over to YouTube and or Facebook, whichever one. So we're streaming live on all three at the same time. So if you're having problems with LinkedIn, you probably aren't even going to hear this. But if you are jumped over to YouTube, usually it's a lot more stable. I don't know what the problems with LinkedIn have been as of recently, but there's been a lot of issues with watching live streams on LinkedIn. So Ian says he's watching from the rig. That is awesome to hear. Thank you, sir. Always good to be able to hear somebody's watching from the rig. And Jocelyn watching from Abu Dhabi. Thank you, sir. Do appreciate it. All right. As y'all know, oh, I forgot to bring it up. Oops. Here we go. Actually, let me do this first. I'm getting my order of operations mixed up here. There you go. All right, guys. It is time now. If you would like to win yourself a drill bit. Oops. There it goes. Like it's chewing. Like we're drilling through the Corva formation. All right. If you guys would like to be able to win yourself a drill bit, put in hashtag Corva on the screen right now, and we will get you one of these drill bits sent off. We've got a whole box of them back there. So we're shipping these things off pretty quick. I don't know what color we got back over there. Blue? Blue. We've got blue ones. We've still got a couple more of these Aggie colored ones. So if you're an Aggie and you want one of these, let me know. All right. Type in hashtag Corva right now. We really do appreciate them being a partner of the show. And this is your Corva Insight of the Week.
In 2005, Mr. DWIS introduced the mechanical specific energy to the oil industry, which has become a widely used term for drilling optimization. Despite some debates about its capability for this purpose, it can be used as a trending tool instead of accounting for the absolute value. To further standardize the MSc terms, many experts in the drilling industry have come together to form a standardization committee, and the paper was presented at the 2022 IDCSB conference. The downhole MSc, also known as bit MSc, only computes the mechanical specific energy derived from the bit. An additional version, the total MSc, was created to consider the effect of the drill string efficiency in addition to the bit. Keeping an eye on both the downhole MSc and the total MSc can help identify the root causes of various drilling dysfunctions.
All right. Well, thank you guys so much over there at Corva for that insight. We do appreciate it. I love anything MSc, Fred Dupriest, data related. I'm a junkie for it. All right. Oh, wow. What is that? Oh, that's why that's there. I was like, what's covering up the button? That thing is, there we go. Put the little Vito relaxment thing up there. All right. We've got 15 entries so far. Don't hesitate if you want to. Now is the time to be able to put in hashtag Corva. All right. 5, 4, 3, 2, 1. It'll be 15. Oh, nope, 16. All right, there we go. All right, who is going to be our lucky winner this week? We'll get you a drill bit. Pretty much the rule is send me a DM. Eric from sunny south of France. All right, Eric's been a long time fan of the show. Really do appreciate you being here, man. Always sharing the podcast and stuff. So well deserved. Might have to just send him to Eric. Thank you so much for watching the show. And that was your Corva Insight of the Week. That was absolutely amazing. All right. Now time to be able to get on with the show. Really excited about this one. If you guys have any questions as we're going through this, please shout them out, put them out there. Oh, Ian Perch says he's tuning in from the Woodlands. Sammy Similar from Hobbs, New Mexico. Martin Kirschman, U Technique Solutions. I don't know what it is. And then 12 1/4 section using heavy HPWBM and TKK on the E. Man, that's a lot of alphabet soup to read off real quick. Sorry. All right. Here's our guest today, Aaron Eddy. Aaron, thank you so much for being on today's show.
Thanks for having me, David.
All right. For those that don't know who you are and what you do, give us your background and what you do here in the industry.
Yeah, absolutely. So I graduated from the University of Calgary with honors degree in computer science back in 2022. I've been working with Pason ever since, so 20 plus years. I started out doing our real-time communications, so live viewer, cloud storage, basically all the communications from the rig. And then I've held various roles through R&D and business development throughout the years. The last 10 years, I've been responsible for automation at Pason. So I've been working with auto drillers, rig integrations, and most recently automated rotary and slide optimization. And so that's mostly what I'll be talking about today. I guess a disclaimer, given my background in computer science, I've learned a lot of what I'll be talking about is my opinion. I've learned a lot from mentors and experts in the industry who know a lot more than me, drilling engineers, partners, directional drillers, the research conference circles, spending tons of times on rigs, of course. So yeah, just a disclaimer. I'll just talk about my experience with automation and where we're at and where I feel we're going.
It's important to get those legal disclaimers out of the way, especially when you work for somebody. So I understand how that goes. All right. So I know that one of the things you wanted to be able to talk about was rotary drilling optimization. Give us your thoughts on that.
Yeah. So I'll just, I guess I'll just back it up. This is probably pretty rudimentary for most people that are listening in, but I think it's good to establish a baseline more or less. So just classic kind of bit cutting interaction. All bits essentially they indent and then they slide, and that's how they destroy rock. So the amount of the indentation and the amount of slide time per minute is essentially your ROP. So how much rock is going to be destroyed per minute. So this is the kind of the underlying methodology more or less behind MSE. So if we have your indentation is the amount of indentation is determined by essentially your weight on bit. So let's say if we were to double our weight on bit, we were to indent the rock twice as much, we'd be destroying twice as much rock per revolution and we'd be going twice as fast. So everything would be great. Same thing with RPM. If you kept the indentation the same and then you were to rotate twice as fast, you'd be cutting twice as much rock per minute. So again, you'd be going twice as fast. So the kind of the fundamentals behind MSE is, as we're adding energy into the drilling process, are we getting that output? So is that going into destroying rock, or is it going elsewhere into some sort of dysfunction? So if we're doubling our weight on bit and we're getting zero output, where is that energy going? So we've done a lot of work. That's kind of the fundamentals. The MSE, I think Corva mentioned it in the Insight, which was pretty good. There's a recent paper that was done. It was 208777 SPE, where a bunch of industry experts, service companies, operators got together and essentially established a standard for total MSE and downhole MSE. As I mentioned, total MSE is essentially axial work, so more or less your weight on bit plus your rotational work, and that's going to be be.
Oh no, sorry.
No,
sorry,
worries.
Aaron. I don't know why that. I think I just hit the space bar and that like
no problem.
I'm sorry. There's our technical disruption of the day. It's me.
No worries at all. Yeah, so total MSE will be the total rotational work from surface. So essentially your surface RPM times your surface torque plus your downhole rotational work. So your bit RPM times your bit torque, and those are derived from downhole pressure differential pressure and pump output and the properties of the mud motor. And then downhole MSE is essentially just that axial work, weight on bit, plus just the downhole rotational work. So that's the fundamentals. I guess when we get into rotary drilling optimization, we started out back in 2015 doing step tests. So essentially guiding the driller through a series of weight on bit increases, RPM increases, and then mapping that out on a heat map and essentially saying, okay, well, this point, after you've done a couple drill off tests is the sweet spot, and that's basically where the optimal weight on bit and RPM is for minimal MSE, optimal ROP, and minimum other dysfunctions, depending on how the objective function set up. But so we ran that for a couple years. Of course, adherence in the field is always a big problem. You have somebody manually receiving the instruction and then updating the auto driller or top drive parameters to say, okay, well, let's change this and follow what it's telling us. We found in general the stochastic environment of drilling, just the variableness even within a formation is it can be difficult. Essentially when you change a weight on bit and ROP goes up, did that go up because the weight on bit changed, or was there a difference in formation properties? So variable drilling is definitely a challenge. So when we started hooking into automation systems directly into rigs to control them, so hooking into auto drillers and top drive systems, it really opened a whole new, world of algorithms you can try. And we ended up landing on an adaptive control algorithm. That's kind of our primary MSE optimization algorithm that we use, which again is really good for a variable drilling environment. It has no bias towards higher or lower parameters. It's just looking for maximum ROP, minimum MSE, and then it's also looking out for drilling dysfunctions, which I guess is kind of one thing to touch on. These systems or these, I guess, automation agents, if you call them. Ours is an ROP optimizer. There's several others in the industry from different vendors. They're definitely quite different because the problem's quite complicated. But I guess the classic kind of ROP optimization, I think of it more as rotary drilling optimizers, because we're really focused on not just pushing ROP and minimum MSE, but we're also looking out for various dysfunctions such as stick slip, data from downhole tools, even auto driller dysfunction, and essentially backing off parameters or adjusting parameters to minimize those dysfunctions. So rotary drilling optimizer, I think there's an assumption with these things that you plug them in, turn them on, and you just get results. So faster spud to TD time.
That's perfect. Awesome. It's exactly what we need.
Mm-hmm. The easy button.
Yes, exactly.
It ends up. So I guess I kind of mentioned, the process we use. I won't really focus too much on the actual optimization that we use. More the process, I guess, for the rest of today's discussion. The process that we employ kind of around deploying this automation that we find really helps improve the chances of success, as in improved performance, faster ROP, less trips, and just that workflow around it, planning, executing, and analyzing the results for kind of true iterative improvement going forward.
And how much involved in that is the downhole portion of it? Like you mentioned getting data from downhole. How much of that's involved in being able to put together this rotary drilling optimization?
That's a really good question. So we receive the inputs today from downhole tools. We don't, as of yet, we don't do any reaction based on them. We've just relied on our surface models for stick slip, and then in general by proxy, I guess, MSE to minimize vibration. And we've been quite successful with that. It is pretty easy, the way the system's architected to essentially just build in another protocol. So if a tool vendor says, don't go over this shock and vibe or whatever it may be, maybe back off RPM by 50% or do XYZ, it's pretty easy to kind of plug and play a module into the system that will receive that input and mitigate based on it.
Well, we've already got our first couple of questions here. So Brian asks, does it take gamma ray into consideration, which is kind of similar to my question, but more specific? Does it project what the current gamma ray formation is based on in offset data?
Yeah, we don't do anything with gamma ray today. It's something that we're looking into, but more what we do is essentially just plan a roadmap, and I'll talk a little bit about that. The key thing with the roadmap or with the planning process is essentially giving the system, like the system has limits, bounds to work in. So if you think of, I guess, on a y-axis, maybe I have my axial limits, so weight on bit, anything that affects axial force, really, differential pressure, torque, etc. So I have my limits on my axial force, and then I have my limits on my rotational. So we control RPM as well, and essentially those limits give you these bounds to operate in. We work with offset data, and we use tools to essentially analyze that offset data. And the key thing with running the system is you want those limits to be, we use offset wells quite a bit. That's kind of one of the first step we use in this planning process. And you definitely want to increase those limits over what's typically run. So if you're running 35,000 pounds through a formation over and over and you're having no failures, and then if we run the maximum of the automation system with 35,000 pounds, your chances of getting performance improvement is nearly zero, because just turning on the system, back to that initial theory we were talking about, to get more ROP, we're gonna have to be indenting the cutters further. So we're gonna need to be adding more weight. So on the top side, you want to give it a little bit more room for improvement over offsets. And then on the bottom side, you also want to make sure it's able to mitigate things like such as stick slip. And again, auto drawer dysfunction is a big one. Really, whatever the system's seeing, you want it to be able to back off, because you're going to be pushing in some cases, and then you're going to be backing off in other cases. So I guess
it helps there to be able to have a wider range of, like, let's say, like weight on bit, right? You can't just have like, oh, this is what we achieved on the last one. It's got to be between 19 and 21,000.
That's exactly right. Yeah, we usually try to find, or we usually recommend a minimum of a 20,000 pound spread, I guess, between the minimum and maximum, to again allow the system to improve on the top side and mitigate dysfunction on the lower end. I guess the other thing that comes into play, so you have your offset wells, then of course there's your equipment limitations. So these are essentially hard limits from your equipment vendors, which may be differential pressure for the motor, maybe 10% below the max operating pressure, whatever that may be. Your general max weight on bits for the VHA, max ROP for hole cleaning, and maybe max torque for drill string makeup or what have you. So kind of those, you have your offset wells, and then you have your equipment limitations, which come from various vendors that are providing equipment.
All right. So I'm not sure who the Red King is, but thank you for watching. Appreciate it. They said, is this the IDAS we are talking about?
Yes, this is DAS. Yeah.
Okay.
That's the one we use, and there's various flavors.
Brian says, have you seen a difference in efficiency between RSS tools and steerable motors in rotary mode?
We've seen a lot more RSS tools, motorized RSS, particularly in the Delaware, lateral sections, and good performance out of them. I think that technology's come a long way. Our system is pretty, again, with that adaptive algorithm, it doesn't really care what's in the hole or what condition is, what the condition is of what's in the hole. It's just always kind of continuously testing. Okay, am I getting more ROP with higher weight, or equally, can I get the same ROP or even higher with less weight? And it's just constantly testing and adjusting those parameters continuously.
Excellent. All right. I know I kind of threw you off. We've got a couple of other questions, but all right, well, maybe I will just go ahead and finish out what's here. So you input the vibration reading, stick, slip, and lateral vibration from service company. Salim.
Yeah, so we have the system we use. I won't get into. I guess there's I have a note here. There's a paper we published, presented back in March 2020 in Galveston. It's SP 199601. So that has a whole a bunch of details on kind of exactly how our system works. Particularly for stick slip, we use a surface model. So we take in and it just kind of gets a little bit out of my expertise, the details, but I'll try to explain it the best I can. It's essentially a finite element drill string model with the drill string properties. And then we take surface parameters, torque and RPM in real time and estimate a downhole bit and BHA RPM. So essentially a min max. And we've compared that to a lot of different downhole tools, and it works quite well. So essentially on surface, there's just a threshold. Stick slip exceeds this value. We're going to, the way the system works is it basically stops optimization. So it's just going to full stop on ROP MSE optimization. We're going to focus on this dysfunction. And it does so by adjusting weight on bit, typically dropping weight on bit and increasing RPM and seeing if that's helping reduce the dysfunction. Getting direct inputs again from the downhole tools, we haven't. I know that some others are using that and using that information. I'd kind of be curious. We just haven't had a need to yet, primarily in North America. But again, it's pretty easy to work with a vendor, and if they have if either axial shock or lateral vibration, whatever it may be, if it exceeds a threshold, do this, and maybe give them a couple knobs too, like, okay, well, we'll drop by this % or increase this, whatever it may be, a knob for the threshold and a knob for essentially how to adjust the drilling parameters. And it's pretty easy to kind of automate something like that.
Just randomly, we got somebody watching from Oman. So Sadiq, thank you. Oman-Dubai. I don't know if he's in 2 spots at once, but sounds good. Paul Moore asks, can you see vibration from the bit, and can you see the depths the well is sticking? Very interesting.
Again, just we just do that by proxy through MSE, and there's kind of an assumption that minimum MSE is maximum drilling efficiency. We do a lot of downhole analysis after the fact. So back to comparing that to our models that are run on surface. We do get data, in-bit data. We get BHA vibration data, all sorts. But we don't see any of that in real time typically.
All right. I know we've got a handful of other questions, but I don't want to get too far off track. So we kind of went through some of the rotary drilling optimization and the theory there. Talk to me about how to be able to do this within rig integration.
Yeah, absolutely. So there's it's been pretty exciting the last 5 or so years. Technology's come a long way from mechanical rigs to PLC VFD rigs, and now these advanced control systems. So our system, I guess we'll call it a rotary drilling optimizer. We'll call it an automation agent. Sometimes it's built right into the rig system, depending on the vendor or provider. Ours, of course, is a third party from Pason. So one way we hook in is auto drillers. Auto drillers are pretty important. I think they're the importance of them in optimization is sometimes undervalued. You kind of want a good control system, and smooth control is your basis. If you're not drilling smoothly, that's it's a one-way ticket to being turned off, first of all. So typically we like to integrate with the auto driller, or integrate with an auto driller that we provide. It's important that they have automatic gains tuning based on depth and ROP, the bumpless transfer between control loops. So we use our auto driller when it's a mechanical brake handle rig, or if we can get a direct electrical connection to AC VFD, or electrical connection to a disc braking system. So in that case, we'll run our auto driller, and of course, it'll only be weight on bit control, not rotary. Then with newer rigs, with the PLC rigs, where the driller has basically joysticks and an HMI for controlling the palms, drawworks, and top drive. We hook in digitally. So in that case, we're sending set points across to the system, and there's a mechanism for the driller to switch control and give control to the rotary drilling optimizer when the time's right. And then nowadays, there's these more advanced drilling control systems essentially a layer on top of the PLC that these systems contain advanced sequencers like going to bottom, which agent is controlled for a given rig state, handing over control, auto surveys, downlinking, auto tearing, weight on bit. So in that case, we're again digitally integrated with those systems, and they typically have kind of quite a slick mechanism for going back to bottom with reduced parameters, and then handing it over to the rotary drilling optimizer to control from there on out. There's an effort going on that I've been kind of partially involved with. It's called DWIS, Drilling Wells and Interoperability Standards. The website is d-wiz.org. And so they're trying to basically standardize the interface for these agents, whether it be like a downlinking agent, a rotary drilling optimizer, a slide executor, surgeon swab. Essentially, they're standardizing the way that these agents talk to rig control systems, typically these advanced rig control systems. And the goal there is ultimately, like we've done a lot of work with specific contractors to get our system integrated. But the goal of DWIS is essentially to standardize these interfaces. So to just help make these applications more plug and play, and I build it for one contractor, I can run on others. It's a pretty lofty goal. Like today, I find
anytime the industry gets together and tries to come up with a standard, it's a lofty goal.
Yeah, so we'll kind of see how it pans out. Like right now, I find when there's usually the first step is a customer, somebody that wants to run your automation system, and then the contractor or the customer, they all kind of get involved to do the integration. And typically, one side will need to write an adapter. Like a lot of contractors nowadays have these like support for multiple different agents or optimizers. And so if a new one comes by, they'll have their way of doing things. The contractor will have their way of doing things. They kind of get together and one side writes an adapter for the other. But it's all pretty easy because with rotary drilling optimization and some of these things, there's only so many ways you can send set points to an auto driller and hand over control and have a heartbeat for liveliness and things like that. So I've been finding the concepts are always the same. It's just the actual mechanism of sending that data back and forth that can be different.
All right. I had a question just because it was kind of in my head there. As far as like the auto tearing weight on bit, how often is just zeroing out weight on bit an issue in the industry?
Yes, I believe so. The more I talk to, just at these various conferences, I talk to operators and others. You kind of see, you just hear a buzz around the accuracy of zeroing weight on bit. I think these systems, these advanced drilling control systems, are definitely getting a lot better with auto tears, and they're improving rapidly. So I think we'll see an improvement in that going forward. Our system has like just the, I guess, general Pason EDR, not to promote it or anything, but we do our own auto zero algorithm kind of in the background, so we can provide alerts if we feel the zero is off by a certain amount. Just provide an alert for the driller to have a look at it anyway.
Okay. We've got 2 questions here. I'll jump over this one. What would acoustic data help with MSC fracture strengths?
Yeah, good question. Probably outside my purview for the most part. Just in general, downhole data and frequency, I think, particularly real-time downhole weight on bit. Quite often when we get downhole data witzed in at a pulsed up, you're getting them very infrequent, and weight usually isn't included. RPM usually isn't included, but I definitely think getting that actual downhole data from a sensor, you only have a limited bandwidth with the mud pulse communication. So we're hitting on the main points. So the vibration data is probably the most important, your inclination, azimuth, etc., and gamma. and then so it'd be nice to have higher bandwidth and be able to add more sensor and get more sensor data. And I know that's happening in the industry. We haven't plugged into any of that with our automation system at all, but definitely it would help improve MSE.
Yeah. One of these days we'll have faster MWD tools.
Yeah, because the all these motor calculations, and ours is simple as well. It's just the differential pressure to torque ratio, and then to give you your bit torque, and then your the speed to flow ratio for what pump rate is essentially translating to what RPM. But that RPM that's under no load. So as soon as you start putting load under it, that value is incorrect. And most DDRs, I know ours today, they still just use kind of a constant factor there, which is, we know it's off, basically the actual bit RPM.
Yeah. K Jackson says, drilling parameter automation, it helps to get people comfortable to run more aggressive parameters by seeing what the automation can do and the gains in ROP.
I think we found that quite often. It's, I guess, just to go to maybe one of the challenges with automation is definitely buy-in. So there's a lot of different people and personalities involved. And if an operating company wants to run or try an automation system, it's definitely not like, oh yeah, run that and let me know how it goes. It's more of a planning process between the directional vendor, other various vendors, the personnel on site, just making sure everyone's engaged, and let's give this a good go and give it a good run, and then we can evaluate the performance. I think you definitely, we are looking to run more aggressive parameters. That's really how you're going to get those ROP benefits. And we definitely have found that there can be this basically like, oh, it's hands off, the system's doing it, so I'll just let it do it. So they do get more comfortable running a more aggressive parameters when they see that they can be run without damaging things in most cases.
All right, so I want to get back to kind of some of the stuff that we talked about before. So talk to me about planning and execution on being able to do the optimization.
Yeah, the big thing with planning is, again, the communication amongst all parties, getting that roadmap together based on offset wells and experience, giving it some room to improve performance. Usually just we start out with a pretty simple process. We just use simple statistics on offset data, like 50th to 80th percentile, for instance. And usually that 80th percentile, that does give you a bit of a buffer for improvement. I think a big thing that we look at also, so we have our plan for our formations and weight on bit and RPM windows, max diff, max torque, max ROP. And then we have the equipment vendors' hard limitations, so that kind of adjusts things maybe. And then we look at hazards. So particularly interbedded formations. So I guess the Brushy Canyon in the Delaware. There's definitely the Travis Peak in the Haynesville and other formations that are where you kind of have a lot of soft to hard transitions. They can be quite quick. So in those cases, typically, when we analyze the data and we're looking at this offset in the planning stage, we'll typically recommend a depth of cut limit through those formations. We want to mostly optimize for the hard stuff, but we don't want to get too high of depth of cut going through the soft stuff, because you'll get this weight on bit limit for the bit from the bit vendor, which is fine running, except if you're going too high of depth of cut through that soft, and then as soon as like the split second when your nose cutters engage that hard section, all that weight is going to be right on those nose cutters, and they end up digging in and they get tangentially overloaded and can cause a risk of damage. So we and same thing with hard to soft transitions. We typically limit the depth of cut as well to avoid when it punches through that soft section and you start getting speeding up. Those shoulder cutters can get shoulder or gauge cutters can take a lot of load on them because they're still kind of in that hard rock. So yeah, we'll typically employ a depth of cut limit in which we do by back calculating an ROP maximum. And the ROP maximum is nice because then you're using the auto driller more or less to slow down a bit in the soft stuff, or not egregiously slow down, but then when you hit that hard, you're going to go up to max weight instantly, and then the automation system is more or less just optimizing the weight for the hard stuff and letting it just drill through the soft stuff. So that's yeah, kind of the planning, I guess, part of it. Those three things: offset wells and experience, equipment limitations from the vendor, and then any hazard analysis that comes into play. Then execution, I won't talk, of course there's training is always important. Spending a couple days out there with the drillers, getting them familiar. A lot of these systems are new to everyone. They're being installed by contractors. So we partner with our contractor partners, usually have personnel from both companies out there because, one is running the rotary drilling optimizer and what it's doing. The other one is kind of how to run it within their system and just make sure it's performing properly. So we usually spend some time with, of course, with both crews, and then come out on crew change as well. Make sure everyone's comfortable with the system, answer any questions. Of course, we have the luxury of having displays in the operator and directional shacks and in front of the driller, so they can everyone's in sync with what's happening with the system. So it's not just training the drillers, kind of everyone on site. Yeah, so that's.
How difficult has training been here as of recently? Because we've seen a lot of turnover in the industry. We've seen a lot of new people coming in. So are you guys going out to retraining people and then turn around 2 weeks later and having to go right back out there to train a whole new crew with the exact same rig?
Yeah, that's definitely a challenge. Because sometimes we don't get notified of it at all. So in those cases, we usually have teams watching operations and evaluating kind of performance continuously. And once they notice something, then it kicks off. I guess part of that planning stage too that I didn't mention is just a good communication loop amongst all parties. So we typically start off an automation job with we'll be sending out daily updates to a group of people that's been identified, and it can include the company man, drilling engineer, other rig personnel, directional company. So we send out this information on just how the system's been performing, maybe any recommendations, but it also kind of creates this feedback loop for anybody that's on that thread. Okay, they can also communicate back to us and say, well, hey, we're noticing this, what's up? And then we can give guidance, whether it's usually either a tuning of the automation system or it's an operational recommendation.
So as far as the oversight there, what kind of other analysis is taking place as the wells are going on?
Typically we're quite focused on more or less how the system's performing. If we like after the fact, the biggest things we look at are there's a ton of data that comes out of these automation systems that can be quite useful in evaluating how the system's been running and maybe recommend improvements, like continuous improvements going forward, pad over pad or well over well. Particularly limiter analysis is one of the big things that we do. So just a breakdown of what was limiting either through the entire section or specific formations. And if the algorithm's really kind of stuck on a limit and it's saying, let's go, then it comes back to, okay, well, we're limiting, let's say on weight on bid or diff for 60% of the time, the system's saying push. Then it's an evaluation of, okay, well, why is that limiter why is that limiter there? Can that limiter be increased? And if not, is it a BHA component that maybe the vendors, along with the operating company, they can look for to swap out a piece of equipment that will allow to push that limit forward. Because once you get stuck on a hard limit, that's your max. That's as fast as you're going to go, really. So I think that kind of continuous, and this is back to Fred Dupree's ExxonMobil limiter redesign and kind of the fast drill process, just always constantly evaluating, okay, well, what's holding us back? Can we push and extend that limiter? So limiter analysis is a big one. The other one, of course, is failure analysis. So we're pushing the system. There's going to be failures. The big thing is just, okay, well, what can we learn from the failures? What's the system telling us? Is it the bit that failed? If it's the bit, what part of the bit? Was it cone, nose, shoulder? We're kind of, again, we've been working, my drilling expertise is just, again, through attrition, I guess, over the years. We're getting better at essentially being able to look at the data and guess how that bit came out, for lack of a better term. So there's always things. I think the most difficult one is shoulder damage. So usually when we look at the bit, look at the pictures, go back and look at the data, and we put together kind of our best hypothesis of what happened. With shoulder damage, it's, was it stick slip induced whirl where it's heavy lateral vibration on the slip phase? Was it just general whirl where depth of cut was too low and RPM was really high? Was it, or is it this interbedded formations where we're just getting too high of a depth of cut, going from hard to soft transitions? So yeah, downhole data is always gold when we can get it after the fact. So that's just some of the stuff that we look at, kind of limiter review, and then any failure analysis, looking at the data, looking at the conditions of the bit or the motor or whatever happened, and then trying to determine what caused that failure, and then going back and putting that back into that planning process.
Excellent. Any other challenges that you guys are facing with being able to do this automation?
Yes, definitely. There's a lot of challenges. I think it's the space is just, it's really exploding, and it's really new. When I say people, I guess I mean more just kind of the point I was talking about earlier, just the collaboration between all parties. Again, if it's kind of like an operation where, yeah, go run that, turn it on, we want performance improvements, let us know how it works out. That doesn't really work too well. It's better to have planning up front, pre-spud meetings with everyone that's going to be involved, just to talk about, how this is going to run. We're gonna give it a go. If you see these issues, contact these people. That's just I find it's really important to make sure there's buy-in on all parties, both on and off site, to get a successful run. So that's one of them. Rig integrations is again, it's quite new. A lot of these systems are new, so there's just challenges on all fronts, but pretty easy to kind of knock through them with when we get up and running, especially with a new contractor integration. There's it's more or less all hands on deck from both parties, and just having that kind of support to work through the issues, doing commissioning up front. So getting the system installed, doing a test off bottom, simulating on bottom drilling, essentially making sure it's working end to end, so that when we do run, typically we're not running in the surface sections, but once we drill out for intermediate, that commissioning process really helps kind of mitigate that risk that the system's just not going to work when you turn it on. I guess what else? Value is a big one. So of course, yeah, with automation, these systems are expensive all around. There's, I've been talking about people monitoring them and people training. There's a lot of expense aside from just the R&D effort going into these. So, you have to deliver value, perform, which is for our system, like for rotary drilling optimization, that's ultimately faster spud to TD time, whether that's less NPT or faster ROP. That's important, and be able to demonstrate value. And then there's kind of always this, I guess questioning. Usually we can kind of, back to Kate's comment there, we can kind of get a pretty good step change in performance out of the gate, and then it's kind of continuous performance and value going forward. So once they get comfortable to running higher parameters, then you're focused more on, okay, well, the value is mitigating these dysfunctions, and also just preventing failures, and then trying to point out and highlight where the opportunities for that improvement can be made going forward. Because the system works quite well, like with, regardless of what the bit condition is or the motor condition, kind of just continuously adapting based on what it's seeing. And then part of that value is just the commercial relationships amongst all these parties. So there's the automation vendor or the optimizer vendor. Let's say it's a service company or third party. Then there's the contractor who has their system and their integration piece. And then there's so everyone's kind of looking for a piece of the pie, more or less. So the value's got to be there, and it's and just commercially it has to make sense.
All right, so we've got a handful of questions. I want to ask one more question before I turn it over to everybody else's. In the course of your career, so you've been able to see the wave of people looking at and using MSE. In your estimation, how many companies out there are using MSE as a resource to be able to drill?
It's a good question. I know that the training on site to just get drillers to do it is a big effort. And there's several operators that have kind of gone through that and invested time and money in getting, like, really bringing drilling crews in and training them. There's a lot of RTOC drilling going on now, so where you have more of engineering types or ex-drillers, and they're monitoring wells remotely, and so they're strictly focused on performance. For a driller in real time, it's kind of difficult, even for a company man. They have lots to do safety wise and other things going on. It really comes to me. I find it most value when you're comparing to offset wells in real time, and then seeing if it's trending off that offset well. Well, why is that happening, and can we make steps to improve it, or is something failing on us?
All right, so let's jump over here. We got a handful of people asking questions. What other automation advisors besides MSE ROP are you developing for application?
So I guess my main one is tool face control execution. So essentially, there's kind of two pieces to directional. There's the brain, which could be a person or software telling, okay, slide this distance at this tool face, and then there's the execution. So we have a piece for the execution. So given an instruction remotely or on site, essentially execute it. There's some of these are being built directly into the contractor system, and then ours is, of course, a third party that can plug into other systems in various ways.
Sorry, it makes me giggle if you refer to maybe the directional driller is the brain, just to call them the brain. Makes me laugh. Sorry. How much of a different PDC design can be incorporated into MSE as you DOC? I'm not sure. Creating a drilling dysfunction stick slip, for instance.
Yeah, that's a good question. Kind of the way our system works, and I guess what I've seen is it's interesting to see if you're testing different bit designs, can you see a difference in MSE? That's kind of an interesting study or problem. I do know, and I guess I don't know too much about this. There's this hydraulic MSC concept, which I think takes into account nozzles and pressures through the jets out the bit. But again, that's kind of outside my scope of expertise.
No worries. What are the biggest lessons learned in regards to human factors, acceptance, use, graphics interface?
So that's a really good question, because we have different, like, we're operating back to what I was talking about, the integrations. We're operating with our auto drawer. We're operating with third-party PLC systems, and depending where we have our screen, of course, this is probably what John Dwart's getting at. We may not have our screen near where the driller is actually operating. And so
hard to get adoption if they can't see it.
Yeah, so we put typically some basic stuff with the integration on the contractor screen, but really just status and the on-off button, more or less. And then we have our screens, of course, in the company man and the other trailers, which is quite helpful. So we have some alerts. Typically, the system's just optimizing, things are going well. Then we have some alerts when one of our mitigation protocols kick in. It's some high stick slip or auto drawer dysfunction, whatever it may be. I guess we've found over time, and there's probably differing opinions on this, but we found that's okay. Essentially, the plans loaded in. We give alerts when a formation's coming up and the parameters that's going to be changed to. But drillers are getting more and more accepting of just turning it on, letting the system go. And then we provide kind of some of the screens if available to the, again, company man, directional driller, and remote personnel.
All right. Last question here from Duncan Graves, unless anybody else starts to throw some out or grows. Sorry. How do you manage integration of other service companies' data in real time at the rig site whilst maintaining IT security? We often find we have to drop back to WITS over a serial cable for an IT air gap.
So yeah, we're still quite heavily WITS focused. So downhole data is coming through WITS. A lot of our stuff is with more industrial bus protocols now. Like all of our integrations are with Modbus. But most of the service company and data aggregation with our system is through WITS. I guess it works. I guess the air gap, not exactly sure what you're referring to there, but definitely the more industrial bus, like Profibus, Modbus, all those inputs are available. We just see less from the service company side, less integrations that are leveraging those protocols right now.
So Henry has it's kind of a two-parter here with does it work with any drive system, steerable motor RSS or motorized RSS?
Yeah, absolutely. So it's I guess I don't want to say it's dumb, but it's it doesn't have any knowledge of what is downhole, more or less. Of course, if it's a motorized RSS or a conventional motorized system, we have the motor properties to estimate kind of bit RPM and bit min max. But otherwise, it works well with both systems, because kind of the fundamental concept of okay, if I'm pushing more weight, am I getting a linear response in ROP? If I'm pushing more RPM, am I getting a linear response in ROP? And then if I'm not, kind of, am I getting a linear response if I'm backing off? It is the same with all those systems we found.
All right, another one here for Brian. Do you automatically reduce RPM to less than 60 RPM to re-engage the bit with the formation?
Yeah, so that in particular, quite these new advanced drilling control systems. I won't mention, I guess, specific ones, but mostly on the super spec rigs and others, they have automated back to bottom routines that will I think they set the, their call it first or second stage or whatever it is, but they set their go to bottom and even come off bottom RPM. So let's just say it's 30 and then a lower weight, maybe 20,000 pounds. And so the system takes care of going back to bottom, engaging the bit, then ramping up parameters and handing over control to us. So we take over control after that's been done.
All right. Oh, my buddy Tongi Bashir. When assessing the value of the service, is the borehole quality, ease of setting the casing, for example, ever considered, or are the metrics always limited to current drilling run?
Yeah, really good question. We've always talked about that quite a bit. Even particularly, we're looking at that more with the slide execution automation, because the value there is faster slides, less tool face error. So we're kind of looking at specifically like slide to slide comparisons, but borehole quality I think is a big one. And then even with the rotary drilling optimization, it's something we've always talked about, but just never dug into. And we will likely be digging into it more with the slide execution.
I think more and more people are going to start to, anytime you can correlate your service back to borehole quality. And then if you can correlate borehole quality back to production, that's, I think, the holy grail on the drilling side to be able to get that done. So Tongi, thanks for watching, man. I appreciate it. Can it be combined with other vendors' automation services, say Kaizen from NOV, for example, just to mention one?
I think they're separate services. So you kind of have your rotary drilling optimizer, and Kaizen is one, and there's a couple others, and then there's ours, which is DWIS, which I think they're basically separate products. You can only have one running at any given time. Okay. And it's so our system, we don't have like an advisory. Customers ask quite often sometimes, like, oh, how much ROP would you have got more out of this? And it's really difficult to tell because it requires that closed loop feedback. So updating parameters, seeing response, updating parameters, seeing response. And if you say, oh, well, if I would have updated this to this, I would have got this, maybe. It's hard to say.
All right, next one's from Derek Boyd. Anyone else remember having to get or know the tech code to enable widths when no one else knew what they were talking about, and you weren't about to wait on the tech?
Isn't that still a problem? No, we've done, yeah. We've definitely, so we've standardized the widths codes for downhole data just recently, because it's kind of all over the place. So, that the question is, so we have a kind of a more of a spec for standardized RSS, so below the motor, or MWD above the motor, downhole drilling or downhole vibration parameters, standardized set of widths code, WITSML mnemonics. But then just deploying it and getting that type of thing implemented, it's either the MWD vendor changing their widths codes or going into our system and updating the widths codes to their standard. Either or. Ideally, they're coming in standard channels and then displayed with standard names and output it to third-party systems through WITSML with standard mnemonics.
Send me that list and I'll get all the MWD guys on board.
Awesome, I will.
All right, Kate says reduced MSE should equal reduced bit whirl and improve borehole quality.
Yeah, so a good metric to kind of look at by proxy. It'd be interesting to see, between runs with the system, lower MSE and is there improved borehole quality based on that? Based from this discussion, something we should look into. It sounds like a good value add that we knew was always there. We just again haven't looked into it enough.
All right, just any royalties, just send them over to the VDOR locksmith.
Yeah.
Right after we find the VDOR key. Okay, Duncan Gross says, you can't pass a virus over a serial cable using WITS. That sounds like a challenge to me. So it gets called an air gapped as the various systems are not connected through an IP protocol. If you go to WITSML, you end up on a shared network, and that has IT issues between the different companies. WITS works, but a bit 1980s.
Yeah, thanks for explaining that. That's definitely good to know. I know WITS
sounds like very similar to. Sorry, it just sounds very similar to somebody I used to work for. Is they used to say, my notebook or my folder or my pieces of paper don't get viruses. I'm like, true. So kind of same thing here. 1980s.
Phone nowadays.
Yeah. Sorry, you were gonna say.
No, nothing. There's, I guess, WITS. We do WITS over TCP nowadays. In some cases, I don't know how widely we're doing that, but maybe that. Yeah.
This is kind of like what we were talking about earlier, Henry. So, but just for the simple fact that you did ask a question, we can reiterate. Can you put real-time vibration feed into the system for further optimization?
Yeah, so shotgun vibes, definitely. We have that coming in today. We're not using it particularly at this time, but it's set up to. It would only take us a very short period of time to write a kind of a custom mitigation protocol based on shotgun vibe.
Have you guys ever used any of the recorded mode data versus what you guys did in real time to be able to look at, comparison of either, shotgun vibration data, downhole bit MSE? There's several, or at least there was a company specifically I used to work at where we had a downhole weight on bit, downhole torque, bending moment, and RPM, shock vibration at the bit. So there was that data that was captured at high frequency. Have you ever used something like that in comparison to what you had at surface to be able to help, kind of change or, do the analysis after the fact?
Yeah, quite often for analysis. So I guess initially when we were developing the algorithms, there's a bunch of different algorithms you can try, and we used a lot of historical data to drive our simulator. And then your kind of simulation, then you apply that to real life. Again, that downhole data, especially at bit, especially if you get multiple points, it's gold to us. Our data science team is always interested in looking at that, and yes, again, kind of do your assumptions based on service data. Are they real? For instance, the reduced MSE and reduced whirl. Is that what you're seeing downhole? Does that align? And then just constantly kind of reevaluating those assumptions, and if necessary, making updates based on that.
Okay. Well, I think we've gotten through all the questions for today. Aaron, thanks so much for coming on the show. I really do appreciate it. And look forward to be able to see more papers and more continued improvements from what you guys are doing over there at Pason. Any last words, anything you'd like to be able to share with everybody watching out there?
No, just thanks very much for having me. And I'm glad we were able to get together and have this talk. I know we've been talking about it for a while. In general, I kind of, this whole process around automation, I hope that if there's anything anyone got from today, that's kind of it. Just that the system's not kind of set and forget it, and to really see improved performance, we find anyway that you have to employ a certain level of planning, execution, analysis, workflow around it. So hopefully that helps regardless of your selection for automation tools and optimization. Hopefully that helps some successful runs and pad over pad performance improvement.
All right, Aaron, like I said, thank you so much for being on today's show. Really do appreciate it. Thanks for everybody else out there that is watching. Like, share, subscribe. Don't know. Auto driller dysfunction, or detecting auto driller dysfunction. Paul Pastusik is going to be speaking Wednesday. I think it's the SP Gulf Coast section event. So if you're interested, if you've gotten this far in today's conversation and you're in the Houston area, you can make it. It'd be a great luncheon to be able to attend. I'll be headed out, and I'll be there Wednesday. So if you're in town on Wednesday, give me a shout and maybe come have lunch with us there. Trying to think anything else. We don't even know if we have somebody lined up for next week yet. So we'll have probably one more show next week, and then that'll be it for for the year. Hope everybody has. If you guys don't tune in, you don't see me on LinkedIn or whatever. I hope everybody has a wonderful holidays. Aaron, have yourself a wonderful weekend. Thank you everybody out there for watching, and as always, know your industry.
Thanks everyone. Have a good weekend.
The button. There it is.